Welcome to this tutorial over 6.6 rational exponents. Our first key concept is b to the 1 over n power. So for any number b and any positive integer n, b to the 1 over n equals nth root of b. So except whenever b is less than 0 and n is even. So when b is less than 0 and n is even, a complex root may exist. So for example, 27 to the 1/3 power is the same thing as saying the cube root of 27, which is equal to 3. Here is where we have the negative b value, and our n value right here is even. So I have the square root of negative 16, which gives me a complex root, which is 4i. Alright, so example 1a, write a to the 1 over 7 in radical form. So we have our a to the 1 over 7. Our 7 is going to be our n for the form n root of b. Our a is going to be our b value, so we're going to rewrite this as 7 root a. And that's your answer. Example 1b wants us to do the opposite, so we're going to rewrite this as the square root. We're just going to add our 2 there so it's easier to see, of w. So here's our n value and here's our b value. Sorry about that noise. So this is for the formula n root b. So we have our n, we have our b. So this is going to equal b to the 1 over n. So in our case, we're going to have w to the 1/2 power. And that's our answer. Okay, example 2a says evaluate the expressions with radical exponents. So we're going to evaluate 49 to the negative 1/2 power. So since we have a negative exponent, we're going to want to flip our number to be underneath 1. So if it was like a fraction, we would flip it to the other side. So we're going to have 49 to the 1/2 power, because moving it underneath turns the negative into a positive on our 1/2 power. And then we're going to rewrite this as 1 over square root of 49. We know that the square root of 49 is 7, so our answer is 1/7. Another way we could solve this is by just rewriting our 49 as 7 squared, because we know 7 squared is 49, and then that's also raised to the negative 1/2 power. So when we multiply these out, we have a 2 times a 1/2, a negative 1/2. So 2 times negative 1/2 is just a negative 1. And then we can flip it over and we can get 1/7 as well. Example 2b, we're going to evaluate 32 to the 2/5 power. So our n is our 5 down here. So we're going to go ahead and write that in our n place. Then we're going to put 32 on the inside. And since we had a 2 in our numerator on our power, let me rewrite it over here. 2/5. Since we have a 2 in the top, then we're just going to leave that there on the 32. So that's our whole number. We could also show this by rewriting our 32 to the 2/5 power as 32 squared. We're just going to separate the 2 and the 1/5. And then we'll write 2 times 1/5. So then our 1/5 is our 1 over n, so we put the 5 here, and then our 2 is squared, so we just keep it on the 32 there. So now we can simplify our 32. So we have the 5th root of 2 to the 5th power squared. And that's the same thing as saying the 5th root of 2 to the 5th times 2 to the 5th. So since I have 1 2 to the 5th, the 5th root of 2 to the 5th is just 2, and then the 5th root of the other 2 to the 5th is also just 2. So we're going to pull out a 2 times 2, which equals 4. And that's our answer. Alright, our next key concept is about rational exponents. So for any real non-zero number b and any integers x and y, with y being greater than 1, b of x over y equals the y root of b raised to the x power, or you can write it in this way also. You can either put the x power on the b on the inside of the radical, or you can put it on the outside. Now, this works except when b is less than 0 and y is even. In that case, we would have an imaginary root. So for example, here we have 27 to the 2/3. So we're going to pull our n from the previous key concept. Here it's going to be our y. And we're going to pull it out to the front. So it's our y root is 3. And then we're going to put our 27 on the inside. And we can either write parentheses around it and square it all, or we can write it as the cube root of 27 squared underneath that radical. Either way is acceptable. Right here, the negative 16 to the 3/2 power, it's the same thing. We have the second root of negative 16, and we can write the cubed on the inside, or we can write the second root of negative 16 with the 3 on the outside. And in this case, whenever the b is less than 0, so we have a negative here, and we have an even number out here, then we're going to get I on the inside, which in this case we would have 4i. So example 4a wants us to simplify expressions with rational exponents. So we're going to simplify y to the 1/7 times y to the 4/7. Oops, I skipped a problem. Just kidding. We're doing example 3. It's solving equations with rational exponents, but it's a word problem. Sorry about that. So this question says the formula m equals 512 minus 146,230 times b raised to the negative 8/5 exponent can be used to estimate the maximum total mass that a weightlifter of mass b in kilograms can lift using the snatch and the clean and jerk. According to the formula, what is the maximum that a weightlifter weighing 168 kilograms can lift? So we know that B is the mass in kilograms that they can lift using this method. So we know that B is the weight So we're going to go ahead and substitute that 168 that it gives us into the formula. So we're going to have m equals 512 minus 146,230 times 168 raised to the negative 8/5 power. Sorry. And then we're just going to solve for m. So we can rewrite this the way that we learned in the previous example. So we're going to have m equals 512 minus 146,230 times the 5th root of 168 to the 8th power. And since that's negative, we're going to put it all underneath 1. So when you put this into your calculator and you evaluate it, you're going to get m equals 472. So according to the formula, the maximum weight that a weightlifter weighing 168 kilograms can lift is 472 kilograms. Now we're going to do example 4a, simplify y to the 1/7 times y to the 4/7. So whenever we have a value or variable, like y to the 1/7 times the same variable y to the 4/7, all we do is we add the exponents. So we have y of 1/7 plus 4/7. That's how we can rewrite this. And 1 plus 4 equals 5/7. So our answer is y to the 5/7. So example 4b, we're going to simplify x to the negative 2/3. If we know that b to a negative n is what we have here, because we have a negative 2/3 as our exponent, equals 1 over b to the n, then we can rewrite our equation as 1 over x to the 2/3. Now we're going to go ahead and rationalize the denominator. So basically what we're going to do is we're going to look at the bottom here. We have x to the 2/3. Now I'm going to want to multiply the bottom by whatever is going to complete this x to give me x just to the first power. So I need a whole 1, but I have 2/3. So I'm going to subtract 2/3 from 1 to figure out what I need, which is 1/3. So I need 1/3 in my exponent to complete that x and make it a whole 1. So whenever I multiply x to the 2/3 times x to the 1/3, we add our exponents. Whenever I do the top, I have to do the bottom, so I'm going to put x to the 1/3 on top, and then I'm going to end up getting x to the 1/3 over x. And that's my answer. Example 5a wants us to simplify this radical expression. So we have the 6th root of 16 over the 3rd root of 2. So the first thing that we're going to do is rewrite the top and the bottom using exponents instead of having it as a radical. We're just going to raise it to the 1/6 power. So we have 16 to the 1/6 over 2 to the 1/3. And we know that we can rewrite 16 as 2 to the 4th power. So we have 2 to the 4th power to the 1/6 power over 2 to the 1/3 power. So now we use our exponent rules, and we can multiply 4 times 1/6 to get 2 raised to the 4/6, which is just the same as 2/3. And then that's going to be over 2 to the 1/3 power. So now that I have 2 to the 2/3 on top and 2 to the 1/3 on bottom, since our top is greater, our exponent on the top is greater than our exponent on the bottom, we can move this bottom term up by putting a negative on our exponent. So we're now going to have 2 to the 2/3 minus 1/3 to get that to move up. And then this will be in simplest form, and it will give us 2 to the 1/3, or the cube root of 2. And both of those are acceptable answers. Example 5b, we're going to simplify the 6th root of 4 times x to the 4th. So we're going to rewrite this with the exponent. So we're going to have 4x to the 4th to the 1/6 power. We're just getting rid of this radical here. So now that we have that, we can go ahead and simplify what we have on the inside. So we know the square root of 4 is 2, so we're going to write that as 2 squared. And then we can write x squared squared equals x to the 4th. And then we are going to raise all of that to the 1/6 power. Don't forget to bring that down. Now, using our product property that we learned in the previous video, we can apply the 1/6 to both of these terms as separates. So we can have 2 squared to the 1/6 power, and then we can have x squared squared to the 1/6 power as well. So on our 2 squared to the 1/6 power, we can multiply our 2 and the 1/6 to get 2 raised to the 2/6, which we know is just 1/3 once we reduce that. And then we can do our x squared squared multiplied by the 1/6. So we're going to do our 2 here on the outermost parentheses, and we're going to multiply it by the 1/6. So then we're going to end up with x squared to the 2/6 power, which we just said was 1/3. So now we can rewrite this 2 to the 1/3 times x squared to the 1/3, or we can say the cube root of 2 times x squared, and both of those are acceptable answers. Alright, so our last example, 5c, we're going to simplify y to the 1/2 plus 1 over y to the 1/2 minus 1. So we're going to want to rationalize our denominator by multiplying by its conjugate. So we're going to have y to the 1/2 on top plus 1 over y to the 1/2 minus 1 times its conjugate. So that would be y to the 1/2 plus 1, y to the 1/2 plus 1 on top also, because whatever we do to the bottom we have to do to the top. So we're going to multiply those by each other, and we're going to get y to the 1/2 times y to the 1/2, then y to the 1/2 times 1 plus y to the 1/2. Then we're going to do 1 times y to the 1/2, so we're going to add another y to the 1/2. Then we're going to do 1 times 1, which is just 1. Then that's all over y to the 1/2 times y to the 1/2 is y. Y to the 1/2 times 1 is plus y to the 1/2. Negative 1 times y to the 1/2 is negative y to the 1/2. And then negative 1 times positive 1 is negative 1. So once we simplify this, these cancel, and these two we can add together. So we're going to have y plus 2y to the 1/2 plus 1 over y minus 1. And that's going to be our answer. Now just a summary of our concepts that we learned. An expression with a rational exponent is simplified when all of the following conditions are met. It has no negative exponents. It has no negative exponents that are not positive integers in the denominator. It is not a complex fraction, and the index of any remaining radical is the least number possible. So that bottom one means that if I have the cube root of x to the 4th, I can still take out some things from the inside. So it needs to be the least number possible. So I would have to rewrite this as the cube root of just x times x, because I have to take out 3 of them since I have the cube root here. So it has to just be in simplest form. Thanks for watching the tutorial 6.6 over rational exponents. This concludes today's lesson.